Today we're doing section 3.5 day 1 and we're going to be talking about exponential growth and decay. So the general equation for exponential growth and decay is A equals A naught e to the kt. So t is going to be time. A with this little 0 means your initial, like whatever we're dealing with, whether that be a population or a substance. The 0 indicates that's the starting one. The other A would indicate the ending one. And K is going to be kind of like the idea of a constant slope. So we're always going to be finding K in these problems. So for our first example, it says the U.S. population in millions for 5 selected years from 1970 through 2007. In 1970, the U.S. population was 203.3 million. By 2007, it had grown to 300.9 million. Find an exponential growth function that models the data for 1970 through 2007. So the difference between these two is going to be 37 years. So t is 37. And our starting population was the 203, and the 300.9 is the ending. So I have 300.9 equals 200, or 203.3, e to the k times 37. So we're going to divide the 203.3 over, and when I do that, I get 1.48 equals e to the 37k. We are in exponential form, so I'm going to put it in log form. So I have natural log e of 1.48 equals 37k. When I do natural log of the 1.48, I get 0.392 equals 37k. We're going to divide both sides by 37, and we get k equal to 0.0106. So the directions want you to write an exponential growth equation. So the equation would be A equals 203.3 e to the 0.0106 t. So the reason you keep the initial population is that's always going to be our quote-unquote starting population. We take out the ending population because that's going to change for any given year that the problem asks. For letter B, it says, by which year will the U.S. population reach 315 million? So now we're going to replace A with 315, and we're going to solve. So 203.3 e to the 0.0106 t. And the reason our k value is positive is our population is growing over time. So we're dividing by the 203.3. When we do that, we get 1.549 equaling to e to the 0.0106 t. We're going to put it in natural log form, equaling to the exponent. Natural log of 1.549 is going to equal, this is from above, 0.4376. And again, you can use your calculators or you can use Google to verify that. And then we're going to divide by this decimal to get t by itself. And when we do that, we get about 41.28. Now the directions don't want to know how many years, they say in which year. So it's approximately year 2011. So you would add 41 years onto the starting year of 1970. All right, one more example, kind of going over this whole idea. You find k and then you solve it. So this one, next one's a little bit more in depth, and I'm probably going to say a lot of these words wrong, so bear with me. It says, use the fact that after 5,715 years, a given amount of carbon-14 will have decayed to half the original amount to find the exponential decay model for carbon-14. So let's use that first this first part to figure out what our k value is. So we know the equation is A equal A naught e to the kt. So some information that we know is that it's been 5,715 years, so that's our t. And the other fact that we know is whatever the original amount was in 5,000 some years, it ends up being cut in half. So the A I'm going to replace with what the original amount was, cutting it in half. Okay, so notice they don't give us the amount exactly, but they do give us this fact that it's cut in half. So I'm going to divide both sides by this A naught. And by doing that, that cancels out, this cancels out. And on the left side, I'm going to be left with 1 over 2 equals to the E to the 5,715. Okay, it's a comma there, not a period. So we're going to put it in natural log form. So I have ln E of 1 over 2 equals 5,715K. So natural log of 1/2 is negative 0.693147. And then we're going to divide that 5,000 number over. So when I divide that over, I end up getting that my K value is equal to a negative 0.000121. So, and again, the reason the K value is negative is that the carbon-14 is dropping over time, and that's why we get a negative K value. So now we have our general model. We know what our K value equals. So now we're going to move on to the second part of the problem. It says in 1947, earthenware jars containing what are known as Dead Sea Scrolls were found by an Arab herdsman. Don't know how to say his last name. Analysts indicated that the scroll wrapping contained 76% of the original carbon-14. Estimate the age of the Dead Sea Scrolls. So again, kind of like the problem we started with, we don't know exactly how much the initial value was, but I know the ending value was 76% of the original value. So the way we would write this is 0.76 of whatever the original amount was. And now we have a K value to put in. And we're trying to figure out how much time has gone by prior to this 1947 from when they found this scroll. So again, just like the last one, we can divide by this A naught, and it's going to cancel out. So these are gone. These have canceled. So now I'm left with 0.76 equals E to negative 0.000121T. Putting it in natural log form, I have 0.76 here, negative 0.000121T. So we're going to use the calculator. We're going to take natural log of 0.76. When I do that, I get negative 0.274437, equaling to the decimal. We're going to divide both sides by the negative 0.000121, and when I do that, for my T value, I get 2,268 years. So that means in 1947, the scrolls were 2,268 years old. Okay, so if you wanted to know the current age of the scrolls, you would have to take the time between 1947 and the current year today. All right, that's all for today.